Now let us solve this problem here. There are some toy horses and toy clowns on Santa's sleigh. Together, they have 45 heads and 148 feet. Find the number of horses and the number of clowns. So first we need to see what is the unknown in the problem. The unknown is the number of horses and the number of clowns. So number of clowns and number of horses are the unknowns. Let us denote the number of clowns by a variable x and the number of horses by another variable y. So there are x clowns and y horses on Santa's sleigh. Now we have that together they have 45 heads and 148 feet. So we need to see how many heads and feet do they have. So each clown has 1 head and 2 feet. So 1 head and 2 feet. And each horse has 1 head and 4 feet. We will require this information to solve this problem. So each clown has 1 head and 2 feet, whereas each horse has 1 head and 4 feet. Now let us see what is given to us. Together they have 45 heads. So together they have 45 heads. That is, total number of heads of clowns and horses together is 45. This is given to us. Now each clown has 1 head. So x clowns have x heads. Each horse has 1 head. So y horses have y heads. So y horses have y heads. So total number of heads of clowns is x and number of heads of horses is y. So number of heads of clowns is x and number of heads of horses is y. Together they have x plus y heads. So total number of heads of clowns and horses together is x plus y. And it is given that this is equal to 45. Because total number of heads is 45 and we have derived it to be x plus y. So we should have x plus y is equal to 45. So we have x plus y is equal to 45 here. Next is, they have 148 feet. That is, together they have 148 feet. So total number of feet of clowns and horses together is 148. This is given to us. Now, each clown has 2 feet. So x clowns will have 2 into x feet. So x clowns will have 2 into x, that is 2x feet. Each horse has 4 feet. So y horses will have 4 into y feet, that is 4y feet. So number of feet of clowns is 2x and horses is 4y. And together they will have 2x plus 4y feet. So clowns and horses together will have 2x plus 4y feet. And this should be equal to 148. So we should have 2x plus 4y is equal to 148. Now we have got this and this as the 2 equations in 2 variables. In fact, these are 2 linear equations in 2 variables. So let us name them as equation 1 and equation 2 and solve them. So equation 1 and equation 2. Now we need to solve them in order to get the values of x and y. So the coefficient of x here is 1, and in this case the coefficient of x is 2. So they are not the same. The coefficient of y here is 1. Here it is 4. So again they are not the same. So in order to eliminate one of the variables, we need to multiply either one or both of these equations by something. So if we multiply equation 1 by 2, we will have 2x here. And we already have a 2x in the second equation. So we can get rid of x using that. So multiply equation 1 by 2. We get 2x plus 2y is equal to 90. And we write the equation 2 as it is. That is 2x plus 4y is equal to 148. This is what we have. Now, this is positive, this is positive. So we need to subtract these two. So positive becomes negative, this positive becomes negative, and this positive becomes negative. So let us subtract these two. 2x minus 2x gives 0. 2y minus 4y gives negative 2y. This is equal to 90 minus 148 is negative 58. This is what we have. Negative 2y is equal to negative 58. From here, we can get the value of y. Y is equal to negative 58 divided by negative 2, which is 29. So we get the value of y as 29. So y is equal to 29. Now we can substitute this value of y in equation 1 and get the value of x. So we put y is equal to 29 in 1. So we have x plus 29 is equal to 45. This is what we get after putting the value of y in equation 1. X plus 29 is equal to 45. This gives us x is equal to 45 minus 29, which is 16. So this is the value of x. X is equal to 16. So we have solved for x and y. We have taken x to be the number of clowns. So the number of clowns is 16. And we have taken y to be the number of horses. So the number of horses is equal to 29. And this is the solution of the word problem.